this problem, we're asked to graph x squared over 4 plus y squared over 16 equals 1. Now, we should recognize right off the bat, because both x squared, or both x and y are being squared, and there's a plus sign in between the two terms, the x squared term and the y squared term, and it's equal to 1, we know that this represents an ellipse. So in order to graph it, all we need to do is find the major axis vertices and the minor axis vertices. So how do we do that? Well, first off, just to make sure that we're graphing it correctly, we want to identify which is the major axis. Is it horizontal or is it vertical? We know it's centered at the origin because there's nothing being subtracted or added from x or y. It's just x squared, y squared. We look at the denominators and we see that 16 is greater than 4. That means the major axis is up and down. We should have it taller than it is wide by the time we're all said and done. So let's look at the major axis vertices. That's where y equals plus or minus the square root of its denominator. So square root of 16, which equals plus or minus 4. So that means our major axis vertices are at 0, -4, and 0, 4. So we'll go ahead and plot those. 1, 2, 3, 4. 1, 2, 3, 4. We always want to start with our major axis vertices because that way we know how big the graph is going to be. We don't want to find our minor axis vertices, graph those, and then, oh wait, our major axis vertices are off of the graph that we made, and we'd have to change the scale. So we want to find our major axis vertices first, which we did. We identified those because the denominator under y is bigger than the denominator under, or under y squared is bigger than the denominator under x squared. Now we find our minor axis vertices. And that's where x equals plus or minus the square root of its denominator, which is 4. So x equals plus or minus 2. And that means our minor axis vertices are at -2, 0, and 2, 0. Now we'd get decimal values unless we knew the point that would have whole number values. Chances are you're going to have values that are perfect squares that are in your denominators for now. But if we wanted to find additional points, we could plug in an input, get out an output, and plot that point. But we would end up with decimal approximations more than likely. So our vertices suffice. And again, we're at 0, 4, 0, -4, 2, 0, and -2, 0. And then we just connect the dots for our ellipse. So again, we found our major axis based on which denominator was bigger. We found our major axis vertices. We found our minor axis vertices. We plotted those vertices, and then we connected the dots to get our ellipse.